While much of the world continues to debate climate change, water scarcity, and the risk of future food crises, more than 20 countries in East Africa have already witnessed billions of insects wiping out enough crops to feed 35 million people in a single day. They can travel over 90 kilometers within 24 hours, forming biological clouds weighing hundreds of thousands of tons that darken the sky. The world sent millions of dollars in the hope of stopping the disaster, but every effort came too late. When all familiar solutions failed, a paradoxical decision began to take shape, not out of recklessness, but out of calculated desperation. If this enemy could not be destroyed, could humans learn to live with it instead? And when the boundary between catastrophe and solution begins to blur, how does that change life in East Africa? That is the story this documentary will explore. Africa is currently home to more than 1.5 billion people. According to long-term demographic projections, this number could approach 2.5 billion by the year 2050. That means within a single generation, the continent will need to feed nearly 1 billion additional people, while its existing food systems are already overstretched. But hunger in Africa is not a problem of the future. It has existed for decades and continues to worsen. Between 2024 and 2025, approximately 307 million people across Africa are living in a state of prolonged food insecurity. That means 1 in every 5 people does not know where their next meal will come from. By comparison, the global average is closer to 1 in 11. In other words, the situation in Africa is roughly twice as severe as the global norm. The crisis is especially acute in countries such as Sudan, South Sudan, Somalia, Ethiopia, and Kenya, where hunger is no longer a looming threat, but a recurring condition year after year. East Africa was once considered ideal for agriculture with fertile volcanic soils, the deep blue waters of the Nile, and abundant freshwater from Lake Victoria. So what pushed this resource-rich region into such distress? In late 2019, hot winds from the Arabian Desert combined with extreme rainfall over the Indian Ocean to create the perfect conditions for a small creature, the desert locust. Across the cracked, arid landscapes of Somalia and Ethiopia, millions of locust eggs quietly hatched. Each female laid between 150 and 200 eggs. Within just a few weeks, the sky turned into a storm of wings. Vast swarms of locusts moved like dark clouds, blocking out the sun and drowning out all other sounds. According to the United Nations, a single swarm covering just 1 square kilometer, roughly half the size of New York's Central Park, can consume enough food to feed 35,000 people in a single day. And in East Africa, there was never just one such swarm. Scientists describe them as nature's perfect plant-eating machines. They do not tire. They recognize no borders, and they do not respect growing seasons. Desert locusts were once mentioned in the Bible as the 8th plague of Egypt. 3,000 years later, they returned, stronger, faster, and more terrifying than ever before. In Somalia, approximately 247,000 acres of farmland were destroyed in a short period of time. Ethiopia lost more than 40,000 tons of staple grains such as maize, sorghum, and wheat. Kenya recorded hundreds of thousands of acres devastated, causing harvest yields in some regions to drop by 5 to 15% in a single season. Tragically, the FAO had warned of this disaster 9 months earlier, but many East African countries lacked surveillance radar or aircraft for pesticide spraying. By the time the first swarms appeared, it was already too late to respond. For communities that depend entirely on rain-fed agriculture, this was not just a failed harvest. When the locusts moved on, they did not leave behind damaged fields. They left behind a livelihood vacuum, no seeds for the next season, no food reserves, and nothing left to sell or trade. In many villages, food stores emptied faster than aid organizations could arrive. At that point, the question was no longer what the next season would bring, but whether people would survive long enough to see it. And it was precisely at that moment that one truth became impossible to ignore. There was no time left to wait for a perfect solution. Locusts did not emerge in a vacuum. They were the final catalyst in a system that was already fragile. War and internal conflict have prevented millions of farmers from reaching their fields. Trade routes have been severed, storage facilities, preservation systems, and transport infrastructure have been destroyed. Even when harvests do occur, food often cannot reach the places where it is needed. Climate change has intensified every existing weakness. The Sahel and East Africa have endured repeated cycles of drought, followed by extreme rainfall. A single failed harvest can already be catastrophic. 2 consecutive failures can push an entire community into a struggle for survival. And even when crops survive to harvest, post-harvest losses remain severe. In many African countries, between 20 and 25% of food is lost due to poor storage, pests, and inadequate infrastructure, nearly double the global average.
Locust swarms are threatening the food supply of millions.
When fields were stripped bare as if scorched by fire, the world finally responded. The FAO, working in coordination with the British government, deployed a so-called green weapon to the region. Metarhizium acridum, a specialized fungus capable of killing locusts without contaminating the soil. In theory, it was a biological miracle. A single drop could spread across kilometers. But in the harsh realities of East Africa, science lost to the heat. The fungus must be stored below 4 degrees Celsius to remain viable, while many areas of Kenya, Ethiopia, and Somalia lack even stable electricity. Roughly 1/3 of storage facilities were little more than corrugated metal sheds in the desert. As a result, hundreds of batches died before they could ever be deployed. The FAO estimates that, if applied correctly, the fungus could reduce locust populations by up to 90% within 10 days. In reality, billions survived, reproduced, and expanded their numbers by as much as 400-fold after just one rainy season. In a system already strained by war, climate stress, and poverty, no single solution was capable of reversing the situation. After months of crops being devastated, an idea born of desperation began to take shape. If locusts could not be destroyed, perhaps they could be eaten. It sounds insane, doesn't it? But why would anyone do that? When scientists examined the idea more closely, they uncovered something that surprised the world. From a biological standpoint, locusts are protein. In 100 grams of dried locusts, protein content can range from 45 to over 50 grams, significantly higher than beef or chicken. They also contain iron, zinc, and calcium, micronutrients that millions of people in Africa are severely lacking. If a gold mine has been discovered, why not exploit it to its fullest? In 2022, researchers from Makerere University and Egerton University put a bold idea to the test: raising desert locusts in greenhouses with tightly controlled temperature and humidity, 2 factors that determine how rapidly the insects reproduce. The locusts were kept in metal mesh enclosures designed to eliminate any chance of escape, because even a single failure could trigger the very disaster humans were trying to prevent. In theory, the model demonstrated the potential for large-scale reproduction. But a fundamental question immediately emerged. What do locusts eat? In nature, they consume the very crops humans depend on to survive: wheat shoots, legumes, and grains. That contradiction undermined the concept of farming locusts for food at its core. As a result, researchers were forced to search for alternative feed sources that humans do not consume, turning the project into a complex, costly chain of experiments that has yet to move beyond the laboratory stage. While science continued to search for answers, reality in Africa took a different path. In Kenya, the bug picture did not raise locusts. It collected them directly from the wild, exploiting a key biological trait of Schistocerca gregaria. During the day, they are highly active in the heat, but at night, when desert temperatures drop, they become nearly immobile. Local communities were trained to go out at night, gathering locusts as they clustered in the cold, then quickly transporting them to collection points and processing facilities. There, the locusts were cleaned, heat-treated, dried, and ground into a protein-rich powder, transforming a mobile threat into a resource that could be stored and used over time. The critical condition, however, was that locusts must never be collected from areas where pesticides had been sprayed, because the insects absorb any chemicals present on crops. Over time, locust powder began to demonstrate value not only for humans, but for the entire livelihood system of East Africa. When tested as an ingredient in animal feed in Kenya and Ethiopia, livestock showed clear improvements in health and productivity, and according to FAO analysis, each ton of insect protein powder can replace approximately 1.5 tons of imported fish meal, easing cost pressures on farmers. From this, a simple but powerful logic emerged. Locusts feed livestock, livestock feed people, and the land is restored to begin the cycle again. Not as a miracle, but as a cautious form of adaptation within a system under relentless pressure to survive. However, every story has its limits. Manual collection cannot be carried out at a scale large enough to control massive locust swarms. Even in the most effective campaigns, only a few tons of locusts were collected over several weeks, a negligible amount compared to the hundreds of thousands of tons of biomass contained in migrating swarms. The bug picture itself has acknowledged that the most suitable fields for collecting locusts are limited to areas near human settlements, covering no more than about 12 acres. Although it does not solve hunger, the model still creates a very concrete impact. The bug picture pays around 50 Kenyan shillings for each kilogram of locusts collected, equivalent to 45 to 46 US cents. At that rate, 1 ton of locusts yields roughly 50,000 shillings, about the equivalent of a month's income for an informal worker in Kenya. What was once a disaster for crops becomes, in this moment, a source of income that helps people endure hunger. At the same time, farming locusts in controlled environments poses serious biological risks. A single small failure could trigger the very catastrophe humans are trying to avoid. Locusts will not save Africa. But the way people have learned to confront them, not through illusions or miracles, but through caution, pragmatism, and adaptation, reveals something far more important about how societies survive under pressure. It shows how communities respond when time, resources, and options are all running out at once. In a world entering an era of overlapping crises in food, climate, and natural resources, solutions are no longer clean or perfect. They are small, imperfect loops, temporary, fragile, and often insufficient on their own, yet sometimes enough to keep people alive one step longer, while larger systems struggle to adjust. These are not stories of victory, but of endurance, where progress is measured not in breakthroughs, but in avoided collapse. Locusts were once symbols of pure destruction. Today, they also serve as a reminder that even in catastrophe, nature can still present options, not easy ones, not risk-free ones, but real and tangible choices shaped by human judgment. Whether those choices lead to resilience or to new risks depends entirely on how carefully they are used and on how well short-term survival is balanced against long-term consequences. The question, then, is not whether humanity can avoid every disaster. It is this: when disaster strikes, are we clear-minded enough to turn it into part of the solution, rather than creating a new crisis in the process?